Welcome to another deep dive. Today, we're going to explore an industry that's, well, fundamental, but maybe doesn't get discussed enough: dairy farming in South Africa.
Yeah, it's a massive operation down there.
It really is. South Africa is actually one of the continent's leading milk producers. Think about it. Around 360,000 cows getting milked every single day. That's a, significant chunk of the national economy.
Huge scale. Absolutely.
But, and this is the big but, with that kind of scale comes a pretty serious challenge. Water usage is immense.
Massive amounts of water.
And consequently, it generates a lot of wastewater. We're talking specifically about slurry waste.
Yeah.
From the milking parlors.
Right. The manure and the washing water mixed together.
Exactly. And if that's not handled correctly, well, it can become a real environmental hazard, a serious threat.
And that's kind of where the current issue lies, isn't it? The common methods, things like basic settling ponds, they just don't quite cut it. They struggle to meet the national standards for wastewater discharge.
Which raises big environmental flags.
Big time. Concerns about water quality, pollution. But what's interesting, and what we're diving into today, is how this problem is actually starting to be seen as an opportunity, a valuable one.
Okay, so settling ponds have limitations. What else have farmers tried? I know some farms have looked into things like engineered wetlands.
They have, yeah. Engineered wetlands are definitely an option people have explored. They're designed specifically to remove pollutants.
Sounds promising.
Well, yes and no. They work to an extent, but the downside, the sort of kicker, is that they require quite large areas of land.
Land that could otherwise be used for grazing, I suppose.
Precisely. So it's a significant trade-off for the farmers. Space is often at a premium.
So if these individual methods, the ponds, the wetlands, if none of them consistently get the wastewater clean enough to meet those minimum standards, what's the answer? What have people been doing?
That's a really good question. And historically, the approach has often been, a combination of things. You might see aerobic treatments using oxygen combined with anaerobic treatments without oxygen.
Okay, mixing and matching.
Right. And these combinations do have advantages. Like, they tend to use less energy and produce less sludge, which is good. But even then, achieving consistent compliance with those discharge standards, it's remained tricky.
But you mentioned a shift, this idea that wastewater isn't just waste anymore, that it's a resource. Where's that coming from?
It's a real paradigm shift, Yeah. We're realizing that the stuff in the wastewater, the nutrients like nitrogen and phosphorus, they aren't just pollutants to be removed.
Okay, so what are they?
They're potential ingredients. They can actually be transformed into economically valuable bioproducts. Think biofuel for energy.
Wow, okay. Generate power from waste.
Exactly. Or perhaps even more significantly, biofertilizers. Really high-quality, sustainable fertilizers with minimal changes to existing systems, potentially.
That changes the whole equation.
Completely. It's not just about solving a waste problem anymore. It's about creating value. This is super important research, especially when you consider things like, diminishing freshwater reserves globally and the ever-increasing cost of standard NPK fertilizers.
So it's a fascinating idea, turning waste into value, but how do you actually do that? What's the practical, maybe low-cost solution farmers could use?
Well, that's where some really neat science comes in. Researchers from the Institute of Natural Resources and the Durban University of Technology have been collaborating on exactly this.
And what have they found?
They're focusing on a technique called phycoremediation. Sounds complex, but the core idea is pretty elegant.
Phycoremediation. Okay, break that down for us.
It essentially uses algae. Simple algae?
Algae, like pond scum.
Well, specific strains of microalgae, yes.
Yeah?
But incredibly effective ones. The technique leverages the algae's natural ability to, eat. They absorb the nutrients and pollutants, the nitrogen, the phosphorus, directly from the wastewater as they grow.
So the algae literally clean the water by feeding on the bad stuff.
That's pretty much it. Lab experiments have been incredibly promising. They've shown certain algae strains can remove more than 90% of the harmful pollutants from dairy wastewater.
90%? That's huge.
It really is. It's like having this tiny, natural, super efficient cleanup crew working 24/7 in your wastewater. Now, the next step is taking it out of the lab. Field trials are actually being launched now to test and refine it in real-world farm conditions.
That's incredible. Just thinking that these microscopic organisms, algae, could hold such a powerful solution. It tackles the environmental problem, reduces pollution.
Protects water resources.
And it also helps the farmers, right? Supports the sustainability of the whole dairy operation, making sure we're not depleting resources or just, wasting potential value. It's good for everyone long term.
Absolutely. It's a win-win approach.
Yeah.
Protecting the environment while potentially creating economic benefits.
What really stands out to me from this is just how innovative that is, using a natural process, something as basic as algae growth, to solve such a complex industrial problem.
It definitely makes you think, doesn't it? It poses a bigger question, really, for all of us to consider. How many other things that we currently label as waste, how many might actually be valuable resources, just sort of waiting?
Waiting for the right idea.
Exactly. Waiting for an innovative, maybe nature-based solution like this one to unlock their hidden potential. What else are we overlooking?